Okay, welcome back from break. We're going to start off with our first sponsor session. It's coming from VAST, Roberto Dognini, and Maurizio Davini from the University of Pisa. Pisa. I'm tired. It's going to be a joint presentation, so we're going to go ahead and get started.
Okay, can you hear me clear and loud? Fantastico. Thank you very much. And here we are with the first sponsor session of the HPC Advisory Council. Thank you very much for inviting us. It's really a pleasure to be here with you. And I will do my best as a first sponsor session to actually avoid the usual marketing, product marketing, blah, blah, blah. And I'm really thankful to Maurizio Davini, who accepted to be here with us today to actually tell you about a real life story. So we started the journey with Maurizio Davini and the University of Pisa 3 years ago. I will do a brief intro, and then I will move to Maurizio, who will tell you his portion of this story. So what we are talking about is about, in the next 20 minutes, is going to be about moving from the traditional high-performance computing environment that we all know, actually you know much better than me, to a service-oriented high-performance computing and AI environment. And yes, I mentioned high-performance computing and AI because it's clearly a mixed environment, and both of them are still there. And the high-performance computing users are there, and they are still demanding. And when I say they are still demanding, I mean in a service-oriented way. When there is a service, the system has to be there, and the system has to respond, and it has to be up and running in production. So what I'm trying to say is that with AI entering massively in our day-by-day, in your day-by-day activities, the model where actually there is one big cluster, one big high-performance computing system and his associated parallel file system, and then eventually another high-performance computing cluster and another associated, most of the time, parallel file system. This way of building stuff, extremely high-performance oriented, most of the time, I would say naked of additional services, is a question mark. Can we go ahead in this way? And what we are trying to explain is that, what I'm trying to say is that moving to a service-oriented approach is about focusing on an infrastructure that has to be always on and has to focus on users and has to focus on the traditional simulations that are still there. Of course, we have trainings happening, and AI model are, as they said earlier, trainings of models is there, and it's not just the big LLM training of models like Apertus, but sometimes it's also fine-tuning or a retraining of an additional model or the same model that can be based on your own data, sometimes confidential data, sometimes additional data set of additional images and additional files that you have. And this has to be done on the local infrastructure. And on top of that, you have inference that is approaching. And when I say inference, I mean inference is becoming extremely demanding from the performance point of view, but also again from the reliability point of view, because when you are inferring, the system and the data has to be there. And most of the time, again, different protocol, different data set sitting on different system, and this is challenging the current status quo. And when we will approach agents, with agents, this is going to be even more difficult because agents, they will need to have access to a wide range of data set in a very, very quick way. And we all know that most probably the challenge is not going to be about the AI model, but we believe that the challenge is mostly going to be about the access to the data, the access to structured and unstructured data, the access to sometimes video or contents that are really challenging to manage. And then on the other side, also structured data in table formats. And this has to be done very quickly, and this has to be done respectfully of permissions, for example. All of these are challenges that are approaching and are there. And we believe that having the right approach to the data set and to the data management is what is going to give you the possibility to serve your user in a better way. And when we speak about agents, there is another aspect that is important, and as Maurizio told me a few months ago, together with Antonio Cisternino, there is another aspect that is important, and it's about vectors. And when I'm talking about vectors, I mean that there is a sort of new format, and again, you know better than me, but sometimes it's better to repeat the very basic stuff. It's like having a new format of data that is coexisting with structured and unstructured data together on your data platform. And so we have the video, but the video will be automatically, most probably, chunked and then ingested and embedded into a vector database. And then we will have to maintain not just a few hundreds, but most of the time millions or billions or eventually trillions of vector database. And this is going to become more and more challenging. And that's the reason why in the past few years, I would say 10 years, VAST invested a lot of times in developing a data platform that is, on one side, of course, able to give you the performance that your environment requires, but then on the other side is also able to give you the reliability, the data reliability, and the possibility to have on-top functionalities that will offer you the possibility to manage high-performance computing, traditional high-performance computing use case, together with AI. And we invested, for example, in developing, in bringing enterprise-class functionalities like snapshot or replica or multi-tenancy or encryption into the high-performance computing and AI world. And we believe that this did help, Maurizio will tell us, did help Maurizio and University of Pisa in their journey, but will also help you to have a more service-oriented data management. This is what we believe, this is where we are investing, and before we go further into the details of VAST, I wanted to give the opportunity to Maurizio to comment his journey.
Thanks, Roberto. Thanks for the invitation. I am here to support Roberto with a 3-year story of the University of Pisa experience with vast data systems. Don't think about a very big installation. It's around 1 petabytes in total, but it's a different phase story that we set up with VAST. 3 years ago, when we approached VAST was for high-performance computing. So we were looking for a new platform. Consider that this is not the only platform that we have running at the University of Pisa. We have different storage silos from enterprises storage to high-performance computing support storage. So the first approach with VAST was, okay, let's build a VAST solution for InfiniBand. So was the first approach is VAST cluster based on InfiniBand, either on the backplane or on the front end, to support our HPC and AI environment. And this was the first approach that we have. Wonderful results, wonderful stability, wonderful performance. So the idea, after sometimes, was to evolve this platform outside of the HPC and AI world. Why? I have the honor, thanks to Hussein's invitation, to give another presentation today about our infrastructure on our campus network, AI infrastructure on campus network. University of Pisa has a big black fiber network that connects all the buildings. So the university, consider the University of Pisa is a sort of city campus, so it's spread all over the town. And so all our departments, all our buildings are connected by our private fiber. And that gives us the possibility of doing almost whatever we want with the network configuration. So the idea was, okay, let's use VAST as a backplane of storage for the campus. So the upgrades was outside of InfiniBand, but was based on 100 gigabits network and was distributed all around the campus as a storage, as a main storage, of course, due to the fact that VAST supports either SMB or NFS or S3 silos. And so we have a multi-protocol support around the university. And this was another successful story because we are able to distribute 200 gigabits Ethernet around the campus on other small data centers that we have around, but also bring the storage with 10 gigabits on the desktop of people. And then last year, the last evolution until now was to build up a disaster recovery site that is still based on 200 gigabits Ethernet networks, but is used either for disaster recovery, snapshot, backup of part of the data that we have. For example, we have an active backup of satellite data that we support from one of our department's experiments, but also as another silo for distributing storage around the campus. You see the numbers and you see the performance. All these upgrades went to the software upgrades, infrastructure upgrades with no downtime. So no data was lost, no downtime on the storage infrastructure during either the hardware upgrade or the necessary software upgrades that we went to.
So let me make the point here. So it's 3 years that he is in production, and when I asked him, is it working? Yes. When I asked him this morning, of course, I've asked him this morning to double check. The question is, no, Maurizio, tell me, how many minutes of downtime you had in the 3 years? And we went through multiple infrastructure upgrade, and we went through multiple update of the system, and the system is always up and running in production with a disaster recovery and with a data protection enabled. That is, I would say, am I fair if I say it's uncommon in the traditional high-performance computing environment?
Yes, it's true. It's true.
So actually,
we have other platforms that has not been so successful, especially for the availability. I have to say we have never lost data, but for sure we have lost availability with other platforms. This is a screenshot that we have taken from our running environment. You can see that the duplication capability of the software, especially for our data, is very important. consider that this is a screenshot for a silo that's composed of any kind of data. Using VAST as a campus storage seems incredible from the duplication point of view, but we have to consider that we have also user data on top of that for various reasons. And one of the main reasons is vast storage save us our lives during an emergency due to Google Cloud Storage remigration last year. A university, the license for Google Storage for our university was canceled due to budget reason. And we have to do a remigration of all this university storage that we have on Google in less than 1 month back on the VAST system. So consider that a big part of the storage that is used today is from files, video files from lessons, PowerPoints, everything was on Google Storage due to the didactic activity of the university. And this is a possibility that VAST storage gave us to save our lives during the remigration. As I told you before, VAST cluster is a central storage for University of Pisa. Is a mixed use. Cloud storage we use for cloud storage, we use for traditional HPC and AI, and also is backplane storage for genomic systems, for chemical simulation system, and especially for satellite acquisition. So we have a couple of projects doing satellite acquisition. We hope to improve our experience. As Roberto told you before, the experience with VectorDB for AI or the use of advanced analytic functionalities that the platform has that we are not able to use at the best until now. These are almost all that I have to say of the 3 years experience that has been very successful for us.
Yeah, if you want to go back to the previous slide, just 1 sec, I just wanted to highlight 1 sec that this is an after-sales gift that, if I understand well, we unexpectedly received in terms of capacity of the platform, correct, Maurizio?
Yes.
Okay. So, and what we are trying to explain is that we, in a high-performance computing environment, Maurizio is coming from that experience, we started together to enjoy about enterprise functionalities like, again, snapshot, replica, the possibility, for example, to recover a data when a user, for example, is deleting the data by mistakes, and we tested together, it was almost a couple of years ago, the possibility for the user to autonomously recover the data from the snapshot of eventually a couple of hours before. And again, those are functionalities that comes without compromise on performance. That's where VAST invested in the last few years to build a rock-solid data platform with, on top, additional advanced functionalities like the one we mentioned, integrated advanced analytics functionalities, the possibility to have a columnar database, the possibility to have a Kafka-compatible event broker that will give you the possibility to, let's say, stream the data to the platform from different sources. And with the engine that we recently introduced, and Maurizio and Antonio, they will test in the next few months, the engine that actually is an engine inside the platform able to identify events that are happening on the storage, like, for example, a new video that is landing on an S3 buckets, and then trigger a function that can run internally or externally the VAST data cluster, for example, in one of your Kubernetes cluster environment, and then eventually chunk the video and then embed the video into a vector database that is going to be there for your agents to use, or for your agentic application or AI application to use. So that's the mix of rock solid, vast data platform foundation with on top what I usually define the advanced functionalities that are there for you to help you on your daily job. And this is service-oriented. Thank you.
Thank you.
So then you'll talk tomorrow about the infrastructure.
Yeah.
But I'm wondering, what is the dimension of, since it's related to the storage part here, so what's the dimension of your cluster where you are running on the VAST, especially for computing point of view?
Oh, we don't consider that. I will share the numbers later today, okay. But don't think about an Alps side system. But consider that we have almost all the latest technologies, but not in big numbers.
Okay.
So consider some DGX, some XE from Dell, but not big numbers. So our infrastructure is not so big. The network is very high performance in the sense that we have 400 gigs InfiniBand or 400 gigs Ethernet and so on. The characteristic is the campus network, that it's outside the data center.
Okay, thank you.
I think the question Hussein was asking, or I was going to ask, is how would these results change or look like if we had a system like Alps hammering on the storage infrastructure?
Oh, I have no experience with so big system. I have only seen one running in TAC last year that I think has dimension like yours. For what we have seen, about the scalability is quite impressive, especially if you grow. It's something that grows horizontally. You have to add nodes.
I agree the performance is good. We have
Yeah.
I mean the resilience.
Oh, for us, the resilience has never been a problem. So consider that I can share the providers, but for a stability point of view, we really go from hardware upgrades to software upgrades without losing one bit and without losing the infrastructure. So the system was still running, writing data. Consider it is not a big deal, but we have a stream for satellite images that never stops, and we didn't lose any data. Now we have also the snapshot of the same data on another system.
Okay, thank you very much.
Thank you.